So this is the third video in section 3.5. In this video, we're only going to be talking specifically about asymptotes. So if you could go down to the fourth page here, and we're going to define them and then also take a look at them a little bit more specifically. So this gray box says that if P and Q are both polynomials, and we have this polynomial rational function, rational function, not a polynomial, but a rational function, P over Q. And it's written in lowest terms. And we have these real numbers A and B. So part one says that if my y value, that's what f of x is, if my y value is approaching either positive or negative infinity. So I've rewritten this, but I want you to understand that this is the same thing as this is. So it's just two different ways of writing the same thing. So if my y value is approaching either positive or negative infinity, as my x value is getting closer to some number a, then the line x equals a is going to be a vertical asymptote. Now, I've got two different pictures here of vertical asymptotes. And so here's the first one, and you'll notice as my x's are getting closer and closer and closer to a. So the dashed line that you see is a. Notice this x value is getting closer to a, this x value even closer, closer, closer. All of my x values are getting closer and closer and closer to a, but notice what my y value is doing. My y value is going up infinitely. The second example that I'm showing you here is this red dashed line is at A, and this graph here, if I'm moving in this direction, my x is getting close to A. Now it's closer and closer and closer. My x's are all getting closer to A, but notice that my y value is going down. And so that is the definition then of vertical asymptote. As my x's are getting closer to A, my y's are either going up or going down infinitely. On the flip side of that, the horizontal asymptote is going to be when my x's get closer and closer to either infinity or negative infinity. And my y's are getting closer to some b value. All right, so the example that I have on this one, notice that my x's are going towards positive infinity, but this dashed line is at the y value of b, and my y values are getting closer and closer and closer to b. So my x's is going toward infinity, going toward infinity, going toward infinity, but these y's, they're getting closer to that dashed line. Another example of that is this right here. Here, it's the green dashed line that's my b value. So if I can get rid of some of this junk here, my green line is my b value. As my x's are getting closer and closer and closer and closer, in this case to negative infinity, my y values are getting closer to that dashed line, to that b value. So that's the definition then of horizontal asymptote. Now, how do you find asymptotes? So we're going to talk about vertical asymptotes separately from the horizontal asymptote. And the first thing that you need to understand is that your function needs to be in lowest terms, okay? And for your vertical asymptote, so we're going to talk about this one first, vertical asymptotes, the first thing you want to do is you need to set your denominator equal to 0. Set the denominator equal to 0. Solve for x. Whatever makes the denominator 0 is going to be my vertical asymptote. So if A is what makes my denominator 0, then x equals A is my vertical asymptote. Now, for number 2, it says other is asymptotes. We're only going to deal with horizontal asymptotes, but you need to understand that my lab is going to talk about oblique asymptotes. We have cut out all of the questions that have any oblique asymptotes for answers. It may be in the set of directions, and I will show you that in a little bit. But even if it's in the set of directions, you're still not going to have any oblique asymptotes to deal with according to the questions that we have chosen for you in your assignments. So for other, just understand we're only dealing with horizontal asymptotes. So part A there says, if your numerator has a lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Now, the short way of saying that is the top degree is less than the bottom degree. So if the top degree is less than the bottom degree, then you've got a horizontal asymptote at y equals 0. All right, option number 2. If your numerator and denominator have the same degree, so you see down here, my top degree and my bottom degree are equal to each other, then my horizontal asymptote, now this is going to get a little geeky, my horizontal asymptote is going to be a sub n over b sub n. Now look at where I'm getting these from. It's those two values. The way I like to say it, this is the leading coefficient on top and the leading coefficient on bottom. So my horizontal asymptote will be at y equals leading coefficient over leading coefficient. And then last but not least, if my numerator has a greater degree than the denominator has, then there will be no horizontal asymptote. Now let's put this into practice. So you might want to have these things in front of you as we do the next few examples. Just a real quick reflection question here before I jump into examples. Can a graph intersect a vertical asymptote? No, it cannot. However, one of the things that you're going to see either in this video or the next video, that is that, yes, you actually can intersect a horizontal asymptote. You can intersect a horizontal asymptote. All right, so we're going to walk you through here exactly what to do with this example 4. It says to give the equations of any vertical, horizontal, or oblique asymptotes. Again, obliques might be in your instructions or in your directions, but none of the questions that we've chosen are going to have oblique asymptotes. And as I mentioned there, the course is not going to cover oblique asymptotes. The first thing that I always want to work on, always factor as much as you can. So when I take my original question, my original rational function, and I factor the denominator, this is what I get. And remember, vertical asymptotes, this is what makes the bottom 0. Well, I can tell that x equals -2 and x equals 3 both make the bottom 0, so this is where my vertical asymptotes are going to lie. My horizontal asymptotes are going to deal with degrees. So if you look at the degree on top, the degree on top is 1. Remember, degree means highest power. And the degree on bottom is a 2. And if you go back up to your notes, whenever the degree on top is less than the degree on bottom, you're dealing with option A here, and your horizontal asymptote is going to be at y equals 0. All right, next example. So once again, let's factor as much as we can. The only thing I can do is pull out a GCF of 2. Still, nothing can cancel, but that's okay. My vertical asymptote, whatever makes the bottom 0, so this is going to be x equals -1. My horizontal asymptote, degrees. Now, I personally like to look at the non-factored version to be able to get my horizontal asymptotes. So when you look at the degree on top and the degree on bottom, both of them are 1. So when the degrees are equal, remember that we take the leading coefficient on top over the leading coefficient on bottom. So that's how I get y equals technically 4 over 1, but I don't need to write the over 1 part. All right, part C, once again, we'll go ahead and factor the top, have a GCF. Still nothing can cancel, so my vertical asymptote is going to be at x equals 1. My horizontal asymptote, well, the degree on top is 2, the degree on bottom is 1. When the degree on top is higher, there is no horizontal asymptote. All right, in the next video, we're going to be talking about graphing techniques, so stay tuned.